Okay, guys. So, hi everyone. Welcome to the very first episode of GCSE Higher Tier Maths. I'm Zainab and I am the founder of Educate Cloud. Educate Cloud is an online learning platform which specializes in GCSE Maths and A-level Maths. And I'm here to help you to master the maths that you need to succeed. Okay, so every week, what I'm going to be doing is I will be focusing on two lessons covering the most important topics from the GCSE Higher Tier syllabus. So we'll be looking from algebra to geometry to stats to problem solving and start looking at all the strategies that actually work. Okay, so it's going to be 2 times weekly class. There's going to be topic-based breakdown of the lessons, practice questions. Throughout, I'll also be giving you loads of exam tips. So whether you're aiming for a grade 7 or even pushing towards an 8 or 9, these sessions are going to be designed to make sure that you're not just learning, but you're actually understanding the concepts. Okay, so we're going to kick things off with indices, roots, and standard form. Indices are also known as exponents. So these pop up everywhere in GCSE exams. So it's important to get really, really confident with the rules. Okay, so let's start off with looking at a few rules that you will need to memorize and also understand for indices. Okay, so these are some really, really basic rules. So the first one is that when you are multiplying two indices that have the same base, which is really, really key here, that they must have the same base, you basically add up the powers. Okay, so if I, for example, have 2 to the power of 2 times 2 to the power of 3, that's going to give me 2 to the power of 5. Okay, so the bases are the same, you're adding the powers. Okay, when you are dividing, you subtract the powers, okay? But the base again must stay the same. So 4 to the power of 6 divided by 4 to the power of 1, or just 4, is going to be 4 to the power of 5 because you're going to take away those powers, okay? Next, looking at the power law, which is that anytime you've got like a to the power of 5 and we've got a 6 on the outside of the brackets, you just times to get the powers. So it's going to be a to the power of 30 here. And then the negative index law is that any time that you have a negative power, so like a to the power of minus 3 or 2 to the power of minus 3, it's like having 1 over a cubed. Okay, or if that was a 2, that's like 1 over 2 cubed, which is 1 over 8. Okay, and the last one of the simpler power laws is that anything in indices to the power of 0 is just 1. So 2 to the power of 0 is 1, 100 to the power of 0 is also 1. Okay, so these are just some key laws that you just need to know. Okay, so pause the video and note them down. All right, next we're going to have a look at negative indices rules, which we've just covered, but here we can do with an example. So here, 2 to the power of minus 3, that's like having 1 over 2 cubed. And also we've got the fractional indice rule, okay, where anytime you have a indice to the power of a fraction, you root it with the denominator and then square it with the numerator, okay? So 16 to the power of a half, that's like having the square root of 16, which is 4, and then 4 to the power of the numerator, which is 1, which is just 4, okay? Again, if you have like 16 to the power of, let's say, 2/3. Okay, that's not going to work. Let's say 8 to the power of 2/3. That's going to be the cube root of 8, which is 2, and then 2 squared, which is 4. Okay, so that is that. Okay, next, let's have a go at a couple of questions. So simplify the following. Here we can immediately see that we've got m to the power of 5 divided by m to the power of 3. So this is the divide rule. So we have to subtract the powers. So the m stays the same. That's our base. To the power of 5, 5, and then 3, we would just take that away. So it would just be m squared. Okay? The next one here, this is a multiplication rule. But here you've got the x and you've got the y. So here we've just got 5, which stays as 5. X to the power of 4 times x to the power of 2. When you add the powers, becomes x to the power of 6. And then y cubed times y, which is just y to the power of 1, is y to the power of 4. Okay, so here it's just 5x to the power of 6, y to the power of 4. Okay. Next, we will have a look at some of these. So we've already done this question. It's come up twice now. A good one to learn. So 1 over 2 cubed, we can just write it like that. And that will be 1 over 8. Okay, the next one, we've got to find the value of 81 to the power of minus a half. Okay, so the first thing we need to do is write it as 1 over 81. Okay, that will get rid of the minus. Okay, so this is a combination of the negative rule and also fractional indices. Okay, then that'll be 1 over the square root of 81 to the power of 1, which is just square root of 81, so that's 1 over 9. And the next one here, this is basically just doing the same thing to the numerator and the denominator here. So we've got to cube root the 64 and the 125 first, and then square it. Okay, so the cube root of 64, that's 4. Okay, the cube root of 125 is just 5, because 5 times 5 is 25, 25 times 5 is 125. Okay, and then we've got to square it, because we're going to square it by the numerator. Root it with the denominator, square it with the numerator. So that's going to be 16 over 25. Okay, so these are the kind of questions that you can get. You're really likely in the higher tier paper to get questions that combine the fractional indices with the negative indices as well. Okay. Alrighty. Now it's starting to get a little more difficult. So what we would do here, okay, here we are going to split this up. So it's going to be the cube root of 8, okay? And then the cube root of 10 to the power of 6, okay? And we can just times this together. So the cube root of 8, that's just going to be 2. And then the cube root of 10 to the power of 6, well, you can think of that as 10 to the power of 6 to the power of a third, okay? Which is actually just 10 to the power of 2, okay? And you can either leave your answer like this, or if you want to find the exact way of writing it, that would just be 200, okay? So the answer to this one is 200. Next, we are going to do 144 to the power of a half. So here, to the power of a half, meaning we're just going to square root it and then take it to the power of 1, because we're going to root it with the denominator. So that is just going to be 12. And we're going to times it by 1 over 64 cube rooted, okay? Which is basically just 1 over 4, okay? Which is just 12 over 4, which is 3. Okay, so the answer to this one is 3. Now this next one, 3 to the power of 2x is equal to 1 over 18. The way that you can do this is, first of all, you know that it's going to be a negative here, okay? Because you want it as 1 over. Then you would see 3 times what? 3 to the power of what, sorry, is going to get you 81, okay? So 3 to the power of what is going to get you 81? Okay, so that's just going to be 3 to the power of 4. Okay, so 3 to the power of 4 makes 81, but we want to add the bottom, so it's going to be minus 4. Okay, and 2 times minus 2 makes minus 4. So x will just be minus 2. Okay, I went through that one quite fast, but you can pause it and go back over and see how you'd get that. Okay. Okay, the next thing we will look at is standard form. Okay, so standard form is basically a way of writing very, very large or very, very small numbers as powers of 10. Okay, so some numbers are really, really large. Like if you were measuring the size of the universe or the size of something huge, it's going to just take a long, long time to write out all the zeros at the end. Okay, so we'd write it in standard form instead. Or also, if you're looking at like size of like atoms, protons, neutrons, they're going to be really, really small. So we're going to write it in standard form. Okay, so standard form is a times 10 to the n, where a is a number that's between 1 and 9. Okay, it's less than 10, so between 1 and 9, and n is any sort of integer. Okay, so here we have to write the following in standard form. Now, the number that I can create that's between 1 and 9 here is 6.4. So that's my a, 6.4 times 10 to the power of, and if I put a point there, I can count how many I would move to get to the end. So it's 1, 2, 3, 4, 5, 6, 7, and 8. So it's 10 to the power of 8. So 6.4 times 10 to the power of 8 can also be written like this. Okay. Next, we are doing this. So work out 3 times 10 to the 7 divided by 6 times 10 to the 4. First, we're going to do 3 divided by 6, which is just 0.5. Then we're going to do 10 to the power of 7 divided by 10 to the power of 4, which we are going to use our rules of indices because our base is the same. So 7 take away 4, that's 3. So 10 to the power of 3. Okay, so 5 times 10 to the power, 0.5 times 10 to the power of 3. But is this in standard form? Because is this number between 1 and 9? So no, it is not. So we need to times this by 10. And when we times this by 10, we're actually going to divide this by 10. So it's going to be 10 squared. So the answer here is 5 times 10 squared. Okay, so we'll stop there. I am going to attach some questions for you guys to try. So please do try them in the section below. I am also going to be doing these sort of lessons quite regularly, so please stay tuned, please like and subscribe, and hopefully that will give me motivation to continue these sort of lessons. And this is basically part 1 of a series for higher tier students again. So questions that students tend to struggle on in exams. I also am currently doing one-to-one classes, and okay, that's spelled wrong, but I am running some groups, so you can register down below or have a look at my website as well. I do offer students lots and lots of resources and ways to go about their revision. I also offer coaching because exam time, so this time that we're currently in, can be really, really stressful. And so that's why I am doing these lessons. Okay, so please like and subscribe, and hopefully I will see you very, very soon. Bye.